Hello, welcome to this presentation. I'm very pleased to be part of the event. So this is my first time at the JavaFX or JFX Days. Today we will talk about NativeFX, which is a very nice library that allows you to interact between native and JavaFX content. So a little bit about me. I just had a very nice postdoc time in Frankfurt, and now I moved to a new now I moved to a new company, so this is very exciting for me because this is just a couple of weeks ago, and I will continue to work on JavaFX libraries there, which is really exciting for me. I'm the main developer of VRL Studio. I don't know if you have seen that already. It's still written in Swing, even though parts of that are already ported to JavaFX, but it is like the largest application. It's a visual programming environment I'm working on, and I try to find as many use cases as possible for JavaFX in there. You can find my open source projects at GitHub, and you also find me on Twitter. The company, I told some of you already, they do microfluidics. So they dispense very small volumes of liquids in so-called well plates. And these machines basically look like 3D printers. That's also, why I was interested in it, because like the mechanics and everything looked familiar, but of course it's like they can dispense fluids in the nanoliter and even picoliter scale. So if you, compare that, this is maybe something like a microliter sphere, and then this would be a nanoliter, and a picoliter would be something like this. So this is pretty precise stuff that they create. And of course, such a machine needs software, and that's why I'm very positive we can also use JavaFX in that company. What you see here is a touch display. So each machine has a full desktop computer inside, built into the machine, and you can also hook up an external monitor if you want. And so this is perfect because the touchscreen is something where you can use JavaFX, the touch gestures and everything. The current software also has some integration with camera and like image processing capabilities. So when you look at this is a camera view here. And obviously this is something, it's not easy to accomplish with JavaFX, and that's where NativeFX could be really helpful and help us realize that with JavaFX. Here's another picture where they do like drops. They calibrate the drops so that it can really precisely measure the volume they dispense. Okay, the agenda for today. We will briefly look at a native rendering in Java in general, so AWT, Swing, and JavaFX. Then we do a quick comparison with DriftFX. Tom is also here. He presented it last year. And then we'll look at the NativeFX architecture, the idea behind it, and we'll look at Java and HTML rendering and what you can do with NativeFX and how you can render real web content with it. And we will see some demos, and we'll also discuss everything that you want to discuss, because I think that there might be more applications for rendering native content than just showing camera images or WebGL. There might be a lot of other use cases, and we can discuss that. Okay, native rendering in Swing and AWT, actually. So in AWT, you have these so-called heavyweight components, and the philosophy was that they are rendered by the OS. So the operating system would render the actual components, and you could do native rendering relatively easily because it was a native graphics context that you used. And the downside was you only had a minimal set of components because everything was done natively, and if you say like it's cross-platform, then you have to rewrite the components on each platform, so you keep the number of components small. Swing did another approach. They introduced this so-called lightweight components, and this is kind of misleading because the lightweight components, they are actually more heavyweight in terms of like performance. They are written in Java and are rendered by Java, so they are invisible to the OS, and it's not that easy anymore to actually interact with native content. But of course, there were some exceptions, and you could mix heavyweight and lightweight to some extent if they were not overlapping, etc. And you could achieve that. And the real cool thing about Swing was that you had a rich set of components because it was like basically platform agnostic with very few exceptions. And one example is like if you look at the toggle binding, you see that there is a GL drawable and there is a GL canvas, which is a heavyweight component. So it's an AWT canvas. And then there is a GLJ panel, which was a Swing component, and you really see a performance drop here. And this is problematic because you want to copy the memory on the CPU. Unfortunately, you cannot do texture sharing. I have used the GLJ panel a lot in VRL Studio because I wanted to have this flow visualizations, and the windows should be overlapping and transparent and everything. So, but I sacrifice performance. The good thing is, for my use cases, I don't need really high frame rates. As long as I can get like 30 or 60 frames per second, this is fine. But this is a limitation to keep in mind, and this is also a limitation of NativeFX that we will see later. In JavaFX, I mean, we have one of the nicest APIs in the UI toolkit zoo, and it's much cleaner than AWT and Swing. And I mean, if you know the history of AWT, it was developed under huge pressure. So when they released the first version, this was really a very tight schedule. But the thing is, it's in some areas it's still less capable, like integrating native stuff, and that's why we have those two projects like DriftFX and NativeFX that try to accomplish better interaction between native and JavaFX scene graph content. So now let's just compare DriftFX and NativeFX. DriftFX is very efficient due to texture sharing, and you have little or no CPU load, and the downside, of course, is that you use internal APIs, but I mean, you can't accomplish it any other. There's no public API available, so this is the only way you can do this. And so support for new JDK versions is sometimes more difficult, and that's why I chose to start NativeFX as a side project at the university, and we wanted to use it to show really results of high performance computing. So when you did large scale simulations of neural networks or something, then we wanted to show the geometry and render that, and that was the goal. But the frame rate is not that critical, and that's why NativeFX sacrifices performance for like more stability, because we use a shared memory approach, and the CPU, however, is involved in copying between the two processes or multiple processes that share their buffers with the JavaFX scene graph. Of course, it only uses official APIs, and that's very important for me because I don't have much time to develop this API, and I want to make sure that it really works with new JavaFX releases. And so you can support new JavaFX versions pretty easily, since JDK 11 and JavaFX 11, this was like something where I had to put some effort in because of the module system, but Gluon helped out nicely. I mean, they even added an option to the plugin so that you can select your own OpenJFX independently from like the version modifier, so you can just point to an SDK folder. This was very nice for testing. And so far it works with JDK 11 to 13. I'm pretty sure it will work on JavaFX 14 as well, but I can't promise that. Okay, so now let's have a look at the architecture. The The architecture is divided in two parts. So we have the managed world and the unmanaged world. In the managed world, we have native nodes on the scene graph. So these nodes here. And we have a native binding class, and we can also have a look at it if you want to know the details, which uses J and I to call into C++. But this is kept minimal. So this native stuff here is just a very small portion and very straightforward C++, so that we don't compromise the Java process with too many like native code, because otherwise, I mean, you will basically compromise the benefits of Java, so stability-wise at least. And then we have separate processes. These are called server processes, and they can render content. So you can have several servers, and they will create their own shared memory, and you will just give it a name, and then you can tell the native binding, here I want to connect this node to this server. And this turned out to be pretty simple to implement, and it works relatively well. And we will see whether it also works on Windows, because I had to switch computers. My Mac constantly disconnects from the Wi-Fi, so we'll try it on Windows. So in the managed part, we have a shared memory layout. This is just a simple header file that you can use if you want to connect your own native content. So this is really agnostic to the actual content that you render. In my case, I tried a very simple C++ server that we'll see later without any dependencies, and I tried to add Qt support. So you have a node and can use Qt. Do you know Qt as a toolkit? Yeah, most of you do. And it's a very major toolkit, but it's based on the wrong programming language, unfortunately. So it's based on C++, and I used it a lot before I moved to Java and Swing. And also Qt has the problem that it has introduces a lot of breaking changes into the APIs. That at least was my experience when I started to develop stuff in Qt3. It didn't work with Qt4, and the stuff I developed in Qt4 didn't work in Qt5. It didn't even guess the things, you know, like, yeah, you have to change this or that. It just broke completely, and it said like, yeah, your code is basically garbage. And I started from scratch. And then, of course, you have the compiler SU that you also have to control, like, do you use GCC, CLang, or Windows compilers, MinGV, and whatever. So this is really hard to maintain, at least for me, because this is just a side project. The good thing about this approach is that I only use Qt in a separate process, and the Qt program is pretty small and just uses the Chromium integration. Okay, how does the native rendering work? Before JavaFX 13, this was what I did, and I wasn't really satisfied with it. So maybe you saw the videos I posted a couple of years ago where I just did a prototype on this, and so, like, I wanted to explore whether this is a viable solution. But of course, the performance of this is very bad because you have this pixel writer, and here you set your int buffer, and you do an additional copy in addition to what Qt does when it copies it to the main memory. And this is, yeah, a little disappointing. But now we finally have this update buffer method here, and that improves things a lot. It's not perfect, but it's a very good compromise, and that's also why I, like a couple of years ago, I created this enhancement request, which finally was implemented, and I was very happy about that, because this is a good compromise between community contribution and like opening JavaFX a little bit, so that we are able to actually contribute also native libraries or libraries that use natively rendered content. And for the JavaFX team, this means they don't have to maintain a lot. It's actually API-wise, it's... Hendrik, do you want to say something?
No.
Dirk, do you want to contribute something?
No, you won't make a lot of noise.
Yeah, that's because of the keyboard. It's Apple's fault. So yeah, so we just joked about it. So I have a computer with a broken keyboard, and I have a Surface with a broken OS. So what can you do? There is not the perfect laptop, I think. No. Okay, but at least the native buffer, as I said, like you don't have to change the JavaFX APIs a lot for that. And for the community contributions, I mean, we can integrate webcams, and also, I mean, you used VLC to, right? You use VLC to display videos and everything, so this is really great. So let's look at a basic demo, and that's the point where I get a little nervous, but we will see. Yes, okay, let's keep the annotations. Scary. One thing I just noticed is that Windows has a nice terminal now, so this is great. So it feels a little bit familiar. What we will do is I will show how to compile the native stuff as well. Let me open maybe the Explorer, go to Documents, GitHub, NativeFX. So here you have a regular Gradle project, and you also have some sample servers. And the sample servers, there is a very basic one. So if you don't know much about C++ and don't want to mess with like dependencies, then I would recommend that you just compile the sample server, because it doesn't have any dependencies, despite some header files which are compiled into the binary, so you don't have to worry about it. Let's briefly look at the website. Go to NativeFX. This is what I'm talking about. This one here, pretty boring visualization, we'll see in a moment. But here you see the dependencies that you need. You need a pretty recent Java version. I think you even need Java 13 right now, or at least JavaFX 13, but it also works on Java 11 with JavaFX 13. Of course, you need a C++ compliant compiler. And also on the Java side, you have some JNI code, but this is so small. This is, I think the binaries are like 17K or something, so they will just be added to the jar file. And actually, I just released a version 0.2.1 or something, where the binaries are included. So if you just want to use NativeFX, you can use it without worrying about C++ compilers. But if you want to use the servers, then you should be able to compile C++ code on your OS. So the idea is that you run the server, and then it has some command line options. You at least have to give it a name. So you just call it memory1, and then it will basically start rendering. And if the shared memory existed previously, it will just delete it, because they are kind of persistent, so you really have to make sure that you delete the native memory. And now we will run the Gradle project. So this is just a demo application, and you can easily connect to this memory. I just press connect, and it should display the content, so it even works on Windows. You see the frame rates below. So this is, I think, okay, this is about 60 frames per second. Of course, if you have like a 5K monitor, you will see the frame rates drop. So on this machine, I'm actually lucky. In this case, this machine is faster than the MacBook. And because the MacBook has a higher resolution display. So, yeah, but you can also animate the node just to make sure that, I mean, this is really a JavaFX node. So I can just apply any JavaFX effect. So, and what I just noticed, I didn't even enable the pixel buffer API, but the resolution is so low that it doesn't really matter in this case. But if you have a higher resolution monitor, then you should enable the pixel buffer API, and you can apply JavaFX effects. We'll see later where we see more interesting content. And if I press delete all, then all servers that are connected are requested to terminate themselves and clean up the shared memory. And the good thing is, if the shared memory crashes, the server crashes, the Java application should stay alive. So if I connect again, let's try to. I don't know whether we can crash it, but no. But what you see here is it's just for a second it says not connected to a server. That just means it lost connection because it has to resize the memory buffer. We could also disable this message if you don't like it and just go with a blank visualization or just stretch the image or something. But I found this useful. And if it loses connection, it is supposed to actually show an error message there as well. So let me just kill it. I don't know if it works on Windows, so bear with me. No, it doesn't do anything. It just keeps the buffer. It's supposed to say like error disconnected from server. And yeah, that's basically it. Okay, so we have used two processes to run something inside JavaFX. I think this is pretty exciting. I don't know about you, but for me, the scene graph always was very, very limiting, very exciting, and really nice to use API. As I said, one of the best or the best UI toolkit API in general, but just a little bit limiting. And for the work that I did, it was not enough. But with the new pixel buffers, I think we have a really nice solution, and it's a good compromise between community and the JavaFX maintainers. Do you have questions so far? No questions? Then we just continue. Java and HTML rendering. I mean, we had some kind of HTML in Java for a long time. So Swing had a subset of HTML 3.2. And actually, I liked using it to style my buttons when I started with Swing. It was kind of convenient. But then I noticed it's not really HTML, and the excitement, was like turned into frustration, more or less. And I mean, if that is like as much as styling you can get, wow. And also the problem was if you had like a different look and feel in Swing and it changed the colors, I mean, it wouldn't match anymore. It was basically broken, but I mean, I didn't complain at the time because JavaFX didn't exist. So let's continue with JavaFX and HTML rendering. JavaFX and HTML rendering started very promising, so because it has WebKit integration and no additional dependencies, so you don't have to care about it. And I followed WebKit like from the early days on Linux, where it was still KHTML. I used KDE, and it was a really nice engine, and WebKit certainly was a huge improvement. And it's easy to use. But the downside is it is not real HTML5. HTML5 is a moving target. And when they introduced WebKit integration, first of all, we noticed not all extensions were supported, like WebGL, etc. And also it was lacking. Nowadays, I mean, there are more improvements to WebKit, and I really like that. But it's not up to date, and many web pages had a problem. And also, one thing that really frustrated me when I gave JavaFX tutorials at the university is the Java process crashed many, many times. And I just told the students, like, Java is much better because it's safe and it doesn't crash, and you just only get exceptions. If you handle them correctly, everything works fine. And it crashed, and it just gave a segmentation fault. And they said, what's the difference between Java and, let's say, C++? And then I stopped using the WebKit integration for a while until it got better. But the main issue is that it runs inside the JVM process. And as I said before, running large portions of native code inside the JVM means you basically compromise all the work that went into the JVM. And even browser vendors, I mean, they isolate the processes to like keep as many tabs alive if something goes wrong. And that's a design decision that I personally don't like. I still really like that WebKit integration is there. I don't want to say it's not useful. It's very useful, and I mean there are many editors, for example, that I just integrated, like a web version of Eclipse or something, and you can just plug into the scene graph, and that works nicely. So it's really great. It's there, but there are some limitations. And what can we do about it? Because I mean, complaining is not enough. I did some research early on, and there is a project called JFX Browser, and I got excited and thought, yeah, that's the solution. But then I went to the web page, and it was basically not a solution because it was no solution for me. An interesting approach that I thought about is like using JPro, that you will hear more about later, and just web content. So if you use JavaFX in the browser, then it was very easy to add WebGL support. And I think there was a demo. I just pulled out the screenshot from you. I think, I mean, they are here. They did it a couple of years ago, I think, and I did some experiments myself. That is certainly an approach, but of course I wanted desktop JavaFX to work as well. But this is a nice approach because then you have the full browser experience with no compromises on the WebGL support. My approach that I implemented in Frankfurt was using NativeFX and writing a Qt server that exposes the web engine to the scene graph. And the web engine is based on Chromium. So early on, Qt also had WebKit, but then they moved to Chromium, which is an improvement because they get a lot of more updates and more frequently. And so you have the Chromium down there, and then you have certain types of widgets on top of that. And I created a headless application that just renders into some CPU buffer that is shared. So we create a queue image from a shared buffer and render the web content into that. And that's, of course, a performance issue, but it's a working solution. It's pretty stable. So we actually added this headless Qt to the mix. And as the servers before, you can mix different servers. You can have one Qt server and another server that gives you input from a camera or something. And all of them communicate through the shared memory layout, which is very, very basic. And it also translates mouse events and keyboard events between both processes. The keyboard stuff is not extremely well tested, so there are key combinations that don't work yet. But yeah, let's just have a look at a real demo. So what I do now is I just call this NativeFX Qt and just give it a name, memory1. And it's using a default URL, and if the network works, we should get a nice visualization. I just run the JavaFX application, connect this, and here you see some WebGL. And this, I mean, is not possible with JavaFX 3D. And again, I'm very happy that they integrated 3D support, but this is something much more useful in like for real visualization applications. I can also animate the node, and yeah, mouse events, they still work. And the performance is reasonable. It's not perfect, but reasonable. And here we can try the blurring effect as well. And I can delete everything. And so it stops the server and cleans up the shared memory. So now let's create something else. So we use a different URL, a scientific visualization. Okay, because I switched from my MacBook to this machine, it warns me that the Intel GPU is not really great for WebGL. I mean, what can we do? We'll still use it. And since we saw molecules, I'll just click on the molecule demo, and you see it's working. And again, it's a real JavaFX node, nothing special about it. Yeah, let's try to delete it and try something else. Now let's try to enable Pixel Buffer API. Okay. There is a LiDAR experiment down there. Let's try that one. So here we have the LiDAR example. Also works pretty fast. And so if you have any demanding visualizations you want to accomplish, and if it's HTML5, that should work without problems. We can also navigate to, let's say, YouTube. Let's open this one and let's open something in addition. So okay, it's blocking. Native Qt, build, release. -n, and we call this mem2, and we say we have a URL. Let's say we go just to youtube.com, and we'll see if that works. So memory 1, okay, we still don't have a real graphics card. And memory 2. So let's see whether that works. Database I/O error. I don't know what this is. Let's try again. Maybe we need HTTPS. So this looks much better. And we just run, let's search for JavaFX. So
du wolltest schon immer ein fähiger Programmierer werden und eigene Python-Programme schreiben?
Ja.
Dann belege jetzt meinen umfangreichen Kurs auf Udemy und werde in Kürze...
Just turn off the sound. And now we play the other one in addition. Yeah. So, and now we have the second one, and I'm very happy it even works on Windows. And you can, run as many servers as you like. Okay. That's NativeFX. I also created a couple of repositories to simplify this process. So you get the main repository, as I said before. The interesting thing is that if you build NativeFX, it will also build the C++ code from Gradle. So you really just type Gradle w clean assemble, and it will look for CMake, it will look for the C++ compiler, compile the code, and build it into the jar file. So there's no need to worry about that. Only the compilers have to match. And there's also documentation on how to run the Qt server. And just a couple of days ago, I also started a project called NativeFX HTML5. And this, when it's done, will provide an easier API that runs the server, and you basically have an alternative HTML node. If you need WebGL, you can just use that one. The problem with it was that Bintray didn't allow me to upload the native dependency because I compiled everything for Windows, Mac, and Linux, and it said, no, the Qt dependency is too large, you cannot host it here. So, but this is just, I threw in everything because I didn't know the dependency tree, and it's kind of difficult to figure out all the possibilities because then you need the localization API, positioning API, etc. in for WebKit to really run. But that's something that I will figure out. And of course, this is all open source. It's Apache licensed, so if you want to contribute, it's a very straightforward project. I try to keep things really simple, even though I sacrifice performance. But I mean, what you saw there, it works. It's not like you get only 5 frames per second or something. Yeah, so that's basically the presentation, and we go to Q&A. Questions? Yeah.
The last thing that you've just shown, is that already ready, or?
You mean the HTML?
Yeah.
So yeah, but the dependencies are not there. And the thing is, from the NativeFX side, the thing is ready and published, but the HTML5 thing was just to actually bundle the Qt dependency so you don't have to compile it yourself, and it's just still sitting on my machine, but I will figure it out in a couple of days and upload it and like create smaller chunks of dependencies, and then I can upload it to Bintray, and then you can use it and try it. As I said, I mean, you saw the version number, it's like 0.2 point something, so there is still a way to go. But the fact that I could just switch my MacBook for the Surface and the demos worked shows it's simple enough that you can actually support it. And I totally agree with what Johan said about, like, you have to be sure about the, what can you actually support, because an API is also a promise. Whenever you add a method, I do this or that fancy thing, then this is basically a promise to all the developers and all the users, and you shouldn't promise more than you can handle. And that's why I also kept it simple. It's just shared memory with some event sharing, etc. But you could try it. I mean, if you build the Qt stuff manually, it works. If I find a way to upload the dependencies, it will also work, because Qt, I mean, it's really heavy. It's like the dependencies, it's like a gigabyte or something, so it's really huge. Of course, you can only compile a subset, and then it's maybe 100 or 200 megabytes. That should be, feasible even for Bintray. One thing I should say about event handling is also that I implemented the shared memory layout. It implements support for like having native events. So the server, for example, can tell you, I'm done with rendering the web content. And you could also use the Chromium, JavaScript engine, etc. But this is not implemented yet. But the infrastructure is there for that. Yeah. More questions? If not, thanks a lot for your time.